All right, let's look at the homework 3.6, problem number 6. All right, so we want to find the horizontal asymptote of this function here. All right, so let's do that. All right, so to find the horizontal asymptote, we need to find the limit at infinity. So we're going to just take the limit of this given function at infinity. All right. So let's do that. You can actually do negative infinity too, and you will see that the value you get out of the limit going to positive infinity and the x goes to negative infinity, they actually give you exactly the same value. So I'll just do a positive infinity. All right. All right. So if you plug in and see what happens, you can see that this guy goes to infinity, and the denominator goes to infinity. All right, same thing. Numerator here goes to infinity. This one goes to infinity. So basically, you get infinity over infinity, which means that we have to do a little bit more work. All right. So what we do is let's take care of this first quotient here. All right. So the highest power is 3 on the bottom. So I'm going to multiply, actually divide top and bottom by x cubed. All right. So let's do that. So I'm going to multiply by, let's see, I'm going to put the fraction there first. Right, and then so I'm going to multiply, divide by x cubed. So I'm going to put the 1 over x cubed on top. Right, then I do the same thing to the bottom so that I don't change the value of the limit. So we have that. Right. Then for the second quotient, highest power is the 1. So I'm going to divide numerator and denominator by x. So I'm going to multiply by a fraction. And on top, you're going to have 1 over x. So it looks kind of like that. And then on the bottom, you have to put exactly the same thing. So 1 over x. Right, we have that. All right, then we can just simplify this limit, right? So limit is, let's say x is still going to infinity, right? So I put that limit there, right? Right, let's simplify this. All right, so I'm going to put big parentheses left and the right, parentheses there. All right, so here, I'm going to do the distribute, all right? So distribute the 1 over x cubed to this guy. So 2 x squared cancel out. So you're going to get 4 over x on top. So I'm going to put a fraction there, and which is 4 over x, right? So we get that, right? So 4x squared divided by x cubed gives you 4 over x, right? And the x cubed divided by x cubed, you're just going to get 1 there, right? And the negative 2 divided by x cubed is, of course, negative 2 over x cubed, right? So we got that, right? So this is the first quotient here. And we do the same on top. So you have a 9x divided by x is going to be just 9. So you're going to have a minus fraction. Then numerator is 9. All right. Then you have 8x divided by x is going to be 8. So you have 8 on the bottom. All right. Then let's see, so you have a 3 times 1 over x is 3 over x. So you're just going to put, let's see, plus 3 over x, right? So it looks like this. All right, so this is very easy to evaluate because any finite number divided by infinity is going to approach 0. So first we know that 4 over x is going to approach 0, right? So let's see, let me let me get that. So it's actually a lot of typing here. So this is going to 0, right? And the 2 over x cubed also goes to 0 as well. So I'm gonna go ahead and do that. So here I'm going to have this guy going to 0, right? And the same deal, 3 over x is going to approach 0 because 3 divided by really big number is going to be very close to 0. So we get that, right? From there, we can see that, let's see, first fraction is going to be 0 over 1 minus 0, which is a long way of saying 0, minus, we have a 9 over 8, so which is going to be negative 9 over 8. So I'm just going to put, so this is equal to negative 9 over 8. Let's see, yep, right. So how about that? Right, we got that. So therefore, if the limit at infinity gives you negative 9 over 8, so the equation of the horizontal asymptote would be y equals negative 9 over 8. Right, so let's type it in. Right, so we have y is equal to negative 9 over 8. Right, let's check the answer. All right, I came back and looks like we got the horizontal asymptote correctly. All right. Again, if you wanted to do x goes to negative infinity, you see that all these terms still go to 0, even though it goes to negative infinity. And the remaining numbers, negative 9, 8, and 1, they remain the same. So you're going to get exactly the same the limit here. So you only have one horizontal asymptote, and which makes sense, right? Because this is still a rational function, and we learned that the rational function can have at most one horizontal asymptote. All right, that's it. I hope that this was clear.